All right, so you sent us a whole stack of articles on blockchain.
Yeah, it seems like you're really ready to dig in and go beyond just the buzzwords this time.
Totally. We want to get to the bottom of what this technology is really all about.
Yeah.
Separate the hype from the reality. And we've got some great material to work with.
We do. 9 different sources, in fact. Everything from academic papers to industry blog posts. Some get really technical while others are a bit more high level. Should be interesting to see what we find.
For sure. So, our mission for this deep dive is to, I guess, cut through all the noise and really understand what blockchain is, how it works, what it can do, and maybe more importantly, what it can't do. Sound good?
That's good to me. Let's do it.
Okay, so first things first, right? What is blockchain? If you had to explain it to a friend at a dinner party who's heard the term but doesn't really get it,
Yeah.
how would you break it down?
That's a good one. I think I'd start with the idea of a digital ledger, but instead of being kept in one place, like a bank's database, it's copied across a whole bunch of computers, like thousands of them. That's the whole decentralized thing everyone's talking about.
Right, okay, I'm with you so far.
So each new transaction, like someone sending money or whatever, gets bundled together with others into a block. Think of it like a container for data. And then, this is the cool part, each block is linked to the one before it using cryptography.
Okay, so it's not just one giant spreadsheet floating out there.
Nope, it's like a chain, hence the name blockchain. Each block is linked to the one before it, creating this tamper-evident history of transactions.
Tamper-evident, huh? So how does that actually work? What makes it so secure?
So think of each block as having this unique fingerprint created by something called a cryptographic hash function.
Uh-oh, here come the technical terms.
Haha. Don't worry, it's not as complicated as it sounds. Basically, this function takes any piece of data, could be a transaction, a whole document, whatever, and turns it into a string of characters, like a digital fingerprint. And this fingerprint is unique to that specific piece of data. Even a tiny change to the original data would completely change the fingerprint.
Okay, so it's like if you change even one word in a book, the whole fingerprint is different.
Exactly. And in the case of Bitcoin, the hash function they use is called SHA-256.
SHA-256. Okay, I've seen that before, but honestly, it makes my head spin a little.
Yeah, the details get pretty complex, but the main thing to remember is that it would be virtually impossible to reverse engineer. Imagine trying to create a specific sandcastle and then recreate the exact same one, grain of sand for grain of sand, after it's washed away by the tide.
That's a lot of sand.
Right, and that's kind of like trying to find 2 different sets of data that produce the same SHA-256 hash. It's mathematically improbable.
So that's what makes it so secure.
Yeah.
Because you can't change one block without changing the entire chain.
Right, you got it. And that's how blockchain ensures data integrity, which is a fancy way of saying that you can trust that the information hasn't been tampered with.
Yeah.
And this is really important because remember, with blockchain, there's no central authority calling the shots.
Right, it's all decentralized, which brings us to this whole idea of consensus mechanisms, right?
Exactly, because if you don't have a central authority, like a bank, to verify transactions and keep everything on track, you need another way for the network to agree on what's true. That's where consensus mechanisms come in.
So it's like a set of rules that everyone on the network agrees to play by.
Exactly. And there are different types of consensus mechanisms, each with its own pros and cons. The most well-known is probably proof of work, or POW, which is what Bitcoin uses.
Proof of work, huh?
Yeah.
That sounds pretty intense. What's the deal with that one?
It is pretty intense. It involves computers on the network, we call them miners, competing to solve complex mathematical problems. Think of it like a giant Sudoku puzzle that everyone is trying to solve at the same time, and the first one to find the solution gets to add the next block of transactions to the chain.
And they get rewarded for their efforts, right?
Exactly. They get rewarded with cryptocurrency, in Bitcoin's case, Bitcoin. And because these calculations require a ton of computing power, it makes it really, really difficult for any one person or group to gain control of the network.
So it's like a digital gold rush, but instead of digging for gold, they're crunching numbers.
Haha, exactly. And because it takes so much processing power to find these solutions, it makes the system super secure. But, and this is big, but it also means that proof of work uses a lot of energy. A lot.
Right, that's where you get into that whole debate about blockchain's environmental impact.
Yeah, exactly. And that's why there's been a lot of interest in finding alternative consensus mechanisms that are less energy intensive.
And there's some other options out there, right?
Yeah. There are. One of the most promising is proof of stake, or PO.
Proof of stake, interesting. So how does that one work? Does it involve, actual stakes, like betting on horses or something.
Haha. No, not quite. Instead of relying on raw computing power like proof of work, POS is more about, well, having a stake in the network, literally.
Okay, now you've got me curious.
So in a proof-of-stake system, instead of miners competing to solve puzzles, participants stake their cryptocurrency. This means they basically lock it up as collateral.
So it's like putting your money where your mouth is, showing that you have a vested interest in the network's success.
Exactly. And the more cryptocurrency you stake, the higher your chances of being chosen to validate transactions and add new blocks to the chain.
Interesting. And because it doesn't require all that massive computing power, it's way more energy efficient, right?
Exactly. Now, there are still some, let's say, open questions about proof of stake, like how to prevent certain types of attacks and make sure that the people with the most stake don't end up controlling everything. But overall, it's seen as a really promising alternative to proof of work, especially when it comes to sustainability.
That makes sense. Now, I've also heard whispers about some other consensus mechanisms beyond POW and POS. Anything we should know about those?
You're right. There's a whole bunch of them out there. You've got proof of authority, which is often used in private blockchains, and then there's things like proof of elapsed time, which is interesting, but maybe a bit too technical to get into right now.
Uh-huh. Yeah, let's save those for another deep dive. So it sounds like we've covered a lot of ground here. We've gone from the basics of blocks and chains to consensus mechanisms, but I imagine even with all these cool features, blockchain isn't without its limitations, right?
Oh, for sure. It's not a magic bullet, despite what some people might say.
Right. I mean, you often hear about how blockchain is immutable, like once something is on the chain, it can't be changed ever. But there's got to be more to the story,
Yeah,
right?
you're absolutely right. There's this thing called forks.
Forks? Like in the road.
Exactly. Think of it like a fork in the road, but for the blockchain's software.
Okay, I'm intrigued. What happens at this blockchain fork in the road?
So sometimes changes need to be made to the software that governs a blockchain network, maybe to add new features or improve security or fix a problem. And when this happens, it can actually split the blockchain into two separate paths, two versions of the blockchain, kind of existing simultaneously.
So it's like having two different versions of the same software.
Precisely. And there are two main types of forks, soft forks and hard forks. A soft fork is backward compatible. Think of it like adding a new lane to that road we talked about. The old rules still apply, but there's a new option available.
Got it. So even if you don't upgrade to the newest version, you can still participate in the network.
Right. A hard fork, on the other hand, is not backward compatible. It's like building a completely new road that branches off in a different direction.
So everyone has to upgrade or
Yeah.
they're stuck on the old road.
You got it. And these hard forks can be intentional, like when a blockchain community decides to make a big change to the rules, or they can happen more organically, even accidentally.
Wow, so it can get kind of messy. Even though blockchain is supposed to be all about decentralization, it seems like human decisions and disagreements still play a big role.
Totally. It's fascinating, right? And forks are just one example of how blockchain isn't always as straightforward as it seems. Another big one is the so-called oracle problem.
Okay, the oracle problem, you definitely got my attention with that one.
Yeah.
What's that all about?
So here's the thing. Blockchain is amazing at handling data that's already in its digital world, right? Like transactions, smart contracts, all that. But what about bringing information in from the real world?
Ah, right. It's like blockchain is this whole self-contained system, so how do you connect it to things that are happening outside of that system?
That's the million-dollar question. So for example, let's say there's a smart contract on the blockchain that needs to know the current price of, I don't know, a barrel of oil to execute a trade.
Right, but you can't just have a random person on the internet typing that information in.
Exactly. That's where oracles come in. They act as bridges between the blockchain and the real world, feeding in this external data that smart contracts need.
Okay, so they're like data messengers. But how do you know that these oracles are trustworthy?
Ah, you see, that's the crux of the oracle problem. How do you make sure that the data coming from these oracles is accurate and reliable? And how do you do it in a way that's still secure and decentralized? It's something that developers are still trying to figure out.
It sounds like connecting any new technology to the real world always comes with its own unique set of challenges.
For sure. And speaking of challenges, we can't forget about cybersecurity risks.
Right. Just because something uses fancy cryptography and has all these decentralized features doesn't make it totally hacker-proof, does it?
Not at all. Blockchain is not this impenetrable fortress that some people make it out to be. There are still vulnerabilities that malicious actors could try to exploit.
So even though blockchain itself might be secure, there are still weak points that could be attacked.
Exactly. These could range from bugs in the code of smart contracts to, good old-fashioned human error.
Right, someone accidentally giving away their private keys or something.
Exactly. Or even more complex attacks, like something called a 51% attack. Have you heard of that one?
51% attack, it sounds ominous. Fill me in.
So basically, if a single entity or a group working together manages to gain control of more than half of the computing power on a blockchain network,
Wait, you can do that?
well, it's really, really hard, especially on larger, well-established networks. But theoretically, yes. And if someone did manage to pull it off,
Let me guess, bad things happen.
they could potentially rewrite the blockchain's history. Like, imagine being able to erase transactions or double spend cryptocurrency.
It would be like a digital heist, taking over the network to manipulate the system.
Exactly. So yeah, even though these attacks are rare, especially on big blockchains, they show just how important it is to have strong security measures in place and to be aware of the potential risks.
So, bottom line, blockchain is only as strong as its weakest link, and those weak links could be technical or human.
Exactly. That's why it's important to be aware of both the possibilities and the potential pitfalls of this technology.
Makes sense. Wow, we've covered so much already. Blocks, chains, consensus mechanisms, immutability, forks, oracles, cybersecurity. It's amazing how we're just scratching the surface.
I know. And we haven't even gotten to the really fun stuff yet, how all of this is actually being used out there in the wild.
Okay, yeah, let's get to the real world stuff. I
Yeah.
mean, we've talked about the tech behind blockchain, but what I really want to know is how it's actually being used. Like,
Mhm.
are there real companies and organizations doing cool things with this stuff?
Absolutely. And one of the most exciting areas right now is decentralized finance, DeFi for short.
DeFi, right, right. I feel like I've been hearing that term everywhere lately. But to be honest, I'm still a bit fuzzy on what it actually is.
Yeah, it's definitely one of those buzzwords that gets thrown around a lot. But at its core, DeFi is basically using blockchain technology to create a financial system that's, well, decentralized, meaning it's not controlled by any one entity, like a bank or a government.
Okay, so instead of going through like a traditional bank to get a loan, I could potentially borrow directly from someone else using a DeFi platform.
Exactly. Or you could use it to lend money and earn interest, or trade cryptocurrencies, or even create new financial instruments, all without going through a middleman.
Wow, that's pretty wild. So it's like cutting out the middleman, the gatekeepers of traditional finance.
Exactly. And because it's all based on blockchain, it's inherently more transparent. Every transaction is recorded on the blockchain, so there's a public record of everything. And because of that immutability thing we were talking about earlier.
Right, the whole can't be tampered with thing.
Exactly. It makes it much harder for fraud to occur, at least in theory.
Okay, so DeFi sounds promising, but I'm guessing it's not all sunshine and roses, right?
Of course not. It's still early days, and there are definitely some challenges. For one thing, because it's so new and there's still so much experimentation happening, it can be pretty risky. Like, there have been cases of DeFi platforms being hacked or exploited, resulting in people losing a lot of money.
Right, there's always that risk with anything new, especially in the crypto world.
Exactly. And then there's the whole regulatory landscape, which is, well, it's complicated. Governments around the world are still trying to figure out how to regulate DeFi, and there's a lot of uncertainty there.
Makes sense. It's like the Wild West out there, right?
Pretty much. But even with the risks and uncertainty, I think DeFi has the potential to be really transformative. It could give people more control over their finances, increase access to financial services, and make the whole system more transparent and accountable.
Okay, I'm convinced. DeFi is definitely something to keep an eye on. So what other industries are being impacted by blockchain? I feel like there was a lot about supply chain management in those articles you sent me.
Yeah, supply chain is a big one. And it makes sense when you think about it.
Because it's all about tracking things. And blockchain is great at creating that tamper-evident record.
Right, you got it. So instead of having all these different systems and intermediaries involved in tracking a product as it moves through the supply chain.
Right, from the manufacturer to the distributor to the retailer, all right.
Exactly. With blockchain, you can create a single shared record of everything that's accessible to everyone involved. So you can see where a product came from, who handled it, when it was shipped, all of that.
And if there's a problem, you can trace it back to the source.
Exactly. Which can be huge for things like food safety, where you need to be able to quickly identify the source of any contamination. Or for combating counterfeiting, which is a huge problem for luxury goods, pharmaceuticals, and even things like electronics.
Okay, so it's about transparency, efficiency, and building trust.
Exactly. And we're already seeing real-world examples of this in action. Like, did you know that Walmart is using blockchain to track the origin of its food products?
Really? Wow, that's impressive.
Yeah. They can now trace like a package of mangoes back to the farm it came from in a matter of seconds, which is pretty amazing.
That is pretty cool. Okay,
Oh.
so supply chain management, got it.
Mm.
What about other industries? I know healthcare is one that's often talked about in the context of blockchain.
Oh, absolutely. Healthcare is ripe for disruption, and blockchain has the potential to solve some really big challenges in that space.
Like what?
Well, one of the biggest ones is the whole issue of medical records. Right now, patient data is often scattered across all these different systems that don't talk to each other, which can make it really hard for healthcare providers to get a complete picture of a patient's history.
Yeah, not to mention all the privacy concerns with having your sensitive medical information stored in all these different places.
Exactly. But with blockchain, you could create a secure, decentralized system where patients have more control over their own data and can choose who has access to it.
So it's like giving patients the keys to their own health data.
Exactly. And it could make it much easier for doctors and hospitals to share information securely and efficiently, which could lead to better care, fewer errors, and even potentially lower costs.
Now, that is something I think we can all get behind. More secure, more efficient, and more patient-centric healthcare. Sign me up.
Right. It's definitely an area to watch. And then there's this whole other side of blockchain that's really interesting, digital identity.
Digital identity. Okay, so what's the connection to blockchain there?
So imagine a world where you have a single, secure digital identity that you control instead of having all these different usernames and passwords for every website and app you use.
Wait, hold up. Are you telling me that blockchain could be the end of having to remember a million different passwords? Because if so, I'm sold.
Haha. It's definitely a possibility. So, with blockchain-based digital identity, you could store your information, things like your name, address, date of birth, maybe even your medical history on the blockchain.
Okay. And it would be secure because of all that cryptography and decentralization stuff we talked about?
Exactly. And you'd be in control of who has access to that information. So no more filling out the same forms over and over again every time you need to prove your identity. You could just give permission to access the information stored on your blockchain profile.
That sounds amazingly convenient
Yeah.
and potentially way more secure than the current system.
Exactly. And there are already some companies doing really interesting work in this space. One example is Selfkey, which is a platform that lets you manage your digital identity on the blockchain. You can use it to verify your identity, store documents securely, and even sign transactions.
It's like a digital passport, but way more powerful.
Right. And this could have huge implications for things like online voting, accessing financial services, and even just simplifying our online lives.
Okay, so we've got DeFi, supply chain, healthcare, digital identity. Is there anything blockchain can't do?
Haha. Well, it's not quite magic, but it does seem like the possibilities are pretty much endless. Like, we haven't even touched on things like how blockchain is being used for things like land registries or tracking intellectual property.
Wow. Yeah, it's amazing how this one technology is popping up in so many different areas.
I know. It's like blockchain is this Swiss Army knife of innovation, and we're really just at the beginning of what's possible.
It's almost like the early days of the internet, right? Where people knew there was something big there but didn't quite know what it was going to turn into yet.
Exactly. It's exciting and a little bit daunting at the same time, isn't it?
Totally. But even though it's still early days, blockchain is clearly evolving fast. Are there any challenges or roadblocks we should be watching out for? Like, what could slow down its progress?
That's a great question. And there are definitely some hurdles that blockchain needs to overcome. One of the big ones is scalability.
Scalability, meaning, like, can it actually handle a really high volume of transactions?
Exactly. Right now, many blockchain networks can be pretty slow compared to, say, traditional payment processing systems like Visa or MasterCard.
Why is that? I mean, I get that blockchain is decentralized, but don't all those computers working together make it faster?
It's not quite that simple. You see, with blockchain, every transaction needs to be verified by multiple nodes on the network to make sure it's legitimate. And that takes time.
So it's like a highway, right? The more cars you try to cram onto the road, the more traffic jams you're going to have.
Exactly. So finding ways to make blockchain faster and more efficient is going to be crucial if it's going to reach its full potential.
Makes sense. Any other challenges?
Well, we've already talked about the environmental impact of proof of work, right? So figuring out how to make blockchain more sustainable is going to be huge going forward.
What about that whole Oracle problem we were talking about earlier? That seemed like kind of a big deal.
It is a big deal. Finding secure and reliable ways to get real-world data onto the blockchain is crucial for a lot of these real-world applications we've been discussing.
Right, like that example you gave with the smart contract needing to know the price of oil.
Exactly. And then there's also this issue of interoperability, which basically means getting different blockchains to work together seamlessly.
Right, because right now it seems like a lot of blockchains are kind of like islands, right? They don't
hmm
really communicate with each other very well.
Exactly. And that can limit the technology's potential. If we can find ways to connect these different blockchains, it would open up a whole world of possibilities.
So it sounds like blockchain has some growing pains to work through, just like any new technology.
Yeah.
But the potential is definitely there, right?
Oh, absolutely. And that's what makes this whole space so fascinating to watch. It's full of challenges, opportunities, and the potential to fundamentally reshape so many aspects of our lives.
You know, as we've been going through these articles, there's something that's been kind of bugging me.
Oh,
Well, we've talked a lot about the how of blockchain, right? Like
yeah.
how it works, the technical stuff, the different applications. But I feel like we haven't really dug into the why.
The why?
Yeah, like what are the bigger implications of all this? Most of these sources we've been looking at focus on the practical side, you know? But what about the philosophical side of blockchain?
Ah, I see what you mean. That's a
Yeah.
whole other deep dive right there.
Right, and I feel like it's an important one. Because this isn't just some new piece of software we're talking about. This technology has the potential to, like, fundamentally change how we think about things.
Absolutely. It challenges our assumptions about how systems work, how trust is established, even how we view ourselves as individuals in a digital world.
Okay, yeah, exactly. So where do we even begin with something like that?
Well, I think a good starting point is to consider how blockchain disrupts traditional power structures. For centuries, we've relied on centralized institutions, governments, banks, corporations to be the keepers of trust, the intermediaries. But blockchain offers an alternative.
Right. It's like instead of putting our trust in these big institutions, we're putting our trust in math, basically, in the blockchain itself.
Exactly. It's a shift from trust me to trust the code. And that shift has huge implications.
Huge. Like what happens if we start applying that to other areas of our lives?
Yeah.
Not just finance, but I don't know, voting, healthcare, education.
Exactly. What happens when we start decentralizing power in those areas? It could lead to a more democratic, more equitable world, or it could create new problems that we haven't even considered yet. We're talking about a fundamental shift in how society operates.
It's almost like blockchain is forcing us to rethink some really basic assumptions about how the world works.
It is. And one of the biggest areas where I think we're going to see this play out is in our relationship with data. We've already talked about things like medical records and digital identity. Imagine a world where you own and control your data instead of it being controlled by these big tech companies.
That would be a game changer.
Right. It could change everything. But it also raises a lot of questions, like how do we ensure that data is used responsibly? How do we prevent misuse and abuse?
Yeah, there are definitely a lot of ethical considerations that come along with this kind of technological shift.
Absolutely. And these aren't easy questions to answer, but I think they're questions we need to be asking ourselves now as we're still in the early stages of this technology.
Because once that blockchain train leaves the station,
It's going to be hard to stop. And that's what makes this whole conversation so fascinating, right? We're not just talking about some incremental improvement here. We're talking about a technology that has the potential to reshape society in really profound ways.
it's exciting and a little bit scary all at the same time.
I agree, but I think that's a good way to feel because it means we're paying attention. We're asking the right questions.
Well, on that note, I think we've done enough deep diving for one day.
My brain is definitely full.
Mine too.
Yeah.
But in a good way. This has been such an interesting conversation. We've gone from the nitty-gritty of how blockchain works to exploring its real-world impact and even pondering its far-reaching philosophical implications.
It's been a wild ride, and I think we've just scratched the surface.
Totally. But for now, we'll have to leave it there. A huge thank you to our resident expert for joining us on this blockchain adventure.
Always a pleasure to be here.
And to all our listeners, thanks for tuning in. If you're eager to keep exploring this topic, we'll have links to all the articles we discussed on our website. Until next time, keep asking questions, keep learning, and keep those blockchain brains buzzing.